So here we are evaluating a limit. So our first step is to plug in c. So we are going to plug in 2 for x. So we have 2 minus 2 over 2 squared minus 2 times 2. And that evaluates to 0 over 0. So because it gives us a 0 over 0, we know that we have a hole in our graph at x is equal to 2. And the question is, how are we going to get the limit? So we need to cancel out somehow that little hole problem to find a new function. So what we're going to do is we're going to factor and then cancel. And remember that as you're going through all of this, your goal is to cancel out the hole. So if x is going to 2, it's like that little arrow sign becomes the subtraction sign, and your goal is to cancel out x minus 2 from the numerator and the denominator. So we already have the x minus 2 in the numerator. That's looking very nice. So now we just have to figure out how to factor the denominator so that we somehow get an x minus 2 factor. So if you remember, when we factor, the very, very first question we always ask ourselves is there a GCF? And remember that the GCF is always going to be the smallest exponent. So it's kind of the opposite of what you hear. You hear greatest, but you're actually choosing the smallest exponent on the variable. So here I have an x squared, I have an x to the first, so I will choose for my GCF x. That is what is common to both of those terms that I can bring out in front. Now, when I do that factorization, I still have x. So because I still have x, I still have this limit notation. So we have x minus 2 over x times x minus 2. All right, so it looks like we're making progress here because when we factor, we then see that these x minus 2's cancel, leaving us with a 1 in the denominator, or in the numerator, excuse me. So we have the limit as x goes to 2 of 1 over x. And again, we still have the x, so we still have the limit notation. All right, so if we were looking at just this limit, what we would do is plug in. So that's exactly what we're going to do. We're going to factor cancel. Once the dust settles, we try to plug in again and see what happens. So here I'm going to plug in x is equal to 2. Now, once I plug in, I've lost the x. So that means that I will lose this limit notation. So it will just be 1 over 2, and that is our final answer for the limit. So again, what this is saying is what we have found is that the limit as x goes to 2 of x minus 2 over x squared minus 2x, we are saying that that limit is equal to 1/2. And we did that by factoring, canceling, and plugging in.